those of you that don't remember, all right, that's our goal today, is to really understand what a radian is and how we're going to connect it from degrees to radians. So a radian, okay, right here on page 306, a radian is the measure of an angle that when drawn as a central angle has an arc length equal to its radius. That's a mouthful. Arc length equal to its radius. That is the key. I want you to highlight that or underline it. The arc length is equal to the radius. So what does that mean? So let's just talk about this. So here's a circle, right? This is a radius. Everyone understands this is the radius of a circle? Okay. Do we understand this is the arc of the circle? The part that goes around, Alex? This is the arc. This is the radius. This is also another radii, right? Another radius. This is the angle. Okay, they call it a central angle because it's in the center of the circle. Okay, and it's saying the arc length, so the length of the arc, is equal to the radius. So let's say this had a distance of 6, then this arc should have a distance of 6. They are equal to each other. That is the whole point, is that they are equal to each other. This radius is equal to the arc length. That is what we are saying. Radius equals arc length. Okay. That is the definition of what a radian is. When the radius equals the arc length, the central angle is called a radian. All right, give me 1 second. Just kind of ignore that picture for a minute. Go ahead and read exercise 1 to yourself. Okay, consider a full rotation around any point in the counterclockwise positive direction. What is the arc length S in terms of the radius of the circle for a full rotation? All right, so let's just talk about what a full rotation is. If you went a full rotation, you went all the way around the circle. What is that describing if you went all the way around? That's true, but what's just the distance around the circle called? Perimeter, but we call it a circumference. Okay, so it's saying, it says, what is the length of the arc? So the arc is S in terms of circumference. We're saying the arc is the circumference. Whoops, sorry. This is saying the arc equals the circumference. Okay. Now, what is the circumference formula? Anyone remember that from those good old geometry days? You got a lot of good stuff in there. That's not totally it. Little too much.
Pi d squared.
Oh, kill the squared.
Pi d.
Pi d. Okay, now let's put it in terms of radius because this has a radius in it. How many radii make up a diameter? 2. So we call that 2 pi r. Where was I going with this? What is the arc length S in terms of the radius of the circle? So the arc length is equal to the circumference, and the circumference is 2 pi r. I think that's all we wanted to say there. The arc length is equal to the circumference. All right, based on the definition above and your answer to part D, how many radians are there in one full rotation? All right, so let's take that definition. S equals... Ooh, did we give you the arc length formula? All right, we're going to come back here. So I'm a little choppy this morning, sorry. The arc length formula. Did you do this out in geometry? You think so? I used an S equals, does this look familiar at all? Anybody? Anybody? Natalie? No. S equals theta times R. Does that look familiar? No. Sometimes I call this the SOR formula, just so I can remember it. I don't know if that makes any sense, but SOR, S equals theta R. Okay, now the only key when using this is that this theta must be in radians. Make a note there. Theta must be in radians. All right, so this was more of like an exploratory thing. Based on your definition above in your answer to part A. So our definition above is S equals theta r. And our answer to part A, we just said S is equivalent to 2 pi r. So I'm going to replace this S with 2 pi r equals theta r. So I just replaced my S with what we said it was equivalent to. It says, how many radians are there in one full rotation? Well, if I divide out the r's in one rotation, I should get 2 pi. Sorry. Okay, so what that's saying is in one loop around, draw a circle for yourself, one loop around is equivalent to 2 pi. Okay? Radians. 2 pi radians, because theta is measured in radians. Okay, now I want you to think about this. If one loop around was 2 pi, how much would halfway be around? Just pi, right? I would just go pi around, or pi halfway around. So if one loop around is 2 pi, then halfway is just pi, is what we're saying. All right, so let me do my thought here. All right, so let's take a look at this circle. Rowan, come on up here for a minute. All right, we're going to measure the distance from the center to the radius. So right at the radius there, or right there. Don't cut this one. Okay, well, Jiminy Crickets, every time I touch it, it moves. Oh, now I don't have it. Why does it look so ugly? Guys, I'm having another day this week. I need my... Oh, why does it look so oblong now? Was it? Is this the right distance? Move a little further. Oh, jeez. What is happening? We're going to remeasure. I don't know how to freeze this thing. I don't know how to... Can we reach... Don't go anywhere yet. X squared plus y squared Okay, let's readjust here. Go ahead and not cut my finger again. Okay. I'm going to ignore those marks there. Okay, so we're going to measure the distance of the radius, yes? Everyone with me? This is the radius? About. So what 1 radian is if we take this distance of the radius and we loop it around the circumference. So we're going to try to mark this up and put a little dot where it ends there. That is equivalent, so right about here is equivalent to 1 radian, yes? If the distance of the radius equals the distance of the arc length, we have 1 radian. Okay? Now, how many did we just say should go around the whole circle? It said 2 pi, right? All right, so let's try this. If I do another one, I'm kind of marking where I think that ends. I now have 2 radians. Let's do one more here. Does it get me right to the end? Okay, no, I've got, thank you, 3 radians. Okay, now, think about what we just said. If this whole thing was 2 pi, how much did we say half of it was? Pi. What is pi approximately? 3.14159. How many radians did this turn out to be approximately? 3 and a little more. This is where pi comes from. Okay, it's actually, if you could do this on any size circle, if you measure the radius and you wrap it around, there will always be 3 and a little more. It will always turn out to be pi. That's exactly where pi comes from. Thank you. Okay, so pi is 3.14. All right, so flip back to this. Here's a typical question. It says a golfer swings a club around a pivot point. So can everyone picture a golfer? All right, so here's his pivot point. All right, his pivot foot. Think basketball, golfing, you got a pivot foot. If the head of the club travels a distance of 26 feet and rotates through an angle of 5 radians, what is the distance the club head is from the pivot point? Okay, so here's your golfer, here's your club. You're going to swing this club, right? And you're going to create an arc when you swing the club. Everyone can picture golfing? Right, you're going to swing this club. It's going to create an arc. As it creates that arc, it's all math, my friends. Every time you swing a baseball bat, swing a golf club, it's all math. A golfer swings the club at the pivot point. The head of the club travels 26 feet. What did we just describe? The angle, the radius, or the arc? The arc is 26 feet. And it rotates through an angle of 5 radians. So the angle is 5 radians. What is the distance the club head, so here's the club head after I swing, right? The club head is from the pivot point. So I'm looking for the what? Radius. I'm looking for the radius. Okay, so I'm going to say S equals theta r. That is the arc length formula. We just said the arc is 26 feet. The angle is 5 radians. And we're looking for the radius. So all I have to do is 26 divided by 5, and I've got my radius. So the radius is 5.2. Does this feel like you did this last year at all? None of this? Okay. I can't remember. I really have no idea, but I can ask a geometry teacher just to verify or not. But so that's all this formula is. You have to identify who the arc is, who the angle is, and who the radius is, and you're looking for one of them. Now again, I just want to stress the catch. The catch is theta must be in radians. They told you it was in radians, so you're good to go. Now if it's not, flip the page. Okay? If it's not, you have to easily be able to convert from degrees to radians and radians to degrees. And what did I do? It's very, very simple. Okay, so here's the little cheat sheet. If you're in degrees and you want to go to radians, you multiply by pi over 180. If you're in radians and you want to go to degrees, you multiply by 180 over pi. So what I usually say is what I want goes on top. Okay, if you're stuck, whatever you want is going to go on top. So if I want to convert 50 degrees to radians, what do I want? I want radians, so I'm going to put the pi on top over the 180. Okay, now, we're going to simplify these, and I'm going to encourage you that you really don't need a calculator. Who can I just simply cross off? The zeros, right? So I really have 5 pi over 18. Okay, I have 120 degrees, and I want it to go to radians. So whatever I want goes on top. I'm going to multiply by pi over 180. Again, who can I easily cross off? Zeros. I bet without a calculator you can reduce 12 and 18. What number goes into both? 6. So this becomes 2 pi over 3. Okay, or 2/3 pi is fine. All right, 135. I want radians, so I'm multiplying by pi over 180. Now that one might be a little tougher in your head. Doable, but a little tougher. Obviously, zeros aren't going to cancel. Let's say you did need a calculator. Let's just practice typing in the calculator. I can pull out that fraction tool and do 135 divided by 180. And it should reduce it nicely for me. That just becomes 3 over 4. Just don't lose the what? Pi. 3/4 pi. Negative 30 degrees. Again, I want radians. I'm going to multiply by pi over 180. I don't need a calculator for that. What happens to my zeros? Cancel. 3 and 18. 3 goes into 18, so that's a negative pi over 6. Perfect. 225 to radians. 225 times pi over 180. Again, maybe that's not as obvious yet, but it will be over the next few days. I got a 5 over 4 and keep that pi. Okay. Now again, to go to the other way, convert the following radians to degrees. I want to go from radian to degrees. What I want goes on top. So if I want degrees, I'm now flipping that, and it's 180 over pi. What's going to happen to my pi's? They cancel. And again, I'm sure you can do this in your head. How many 3's go into 18? 6, and there's a 0, so that makes 60 degrees. Negative 2 pi over 5. I want degrees, so I'm going 180 over pi. What happens to my pi's right away? Cancel. Okay. Now 5 doesn't go into 180 nicely, so maybe you're thinking you need a calculator, and that's okay. Again, let's just practice. I'm going to do my negative 2/5 times 180. Totally can do that as well. You could put this over 1 and multiply, 100%. You can type it in this way too. You can multiply that by 2, absolutely. That's 360 over 5. You can, this is saying the same thing, Dree. I can do the 2 times 180 to get 360 and then divide by 5. Or just type it in as the fraction times 180. It'll get you the same thing. Okay. 3 pi over 2. I want degrees, so 180 over pi. Again, I'm going to eliminate those pi's. I'm going to do a little mental math here because I can do 2 into 180. How many times does 2 go into 18? 9, so that makes 90. And I can multiply 3 times 9 in my head, so that makes a 27, and put my 0 on. That's a 270. Five pi over 6 times 180 over pi. Again, my pi's are going to cancel. I can do this one easily in my head as well. 6 goes into 18 how many times? 3, so that's a 30. 5 times 3 is 15, and put that 0 on. That makes that a 150. I'm going to skip this last one for a minute and keep going. Number 3 says convert the following radians to degrees. Note, not all radians are in terms of pi. If they just say radians, then it's in radians. It doesn't have to have a pi in it. So if I want to make 5.8 go in 5.8 radians turn to degrees, I'm going to multiply by who over who? I want what? I want degrees. I want 180 over pi. Now, can the pi's cancel? Is there a pi? There is no pi, right? It says not all radians are in terms of pi. So I'm literally just going to type this in my calculator. Okay, I'm going to say 5.8 times 180 over pi. Okay, and that's how many degrees this is equivalent to. 332.3, I don't know, 2 degrees. Oh, nearest degree, thank you. 332 degrees. Okay, again, not all radians are in terms of pi. If it says the word radians, it's in radians. 4.2 times 180 over pi. I'm literally just going to type that in. 4.2 times 180 over pi. What is that, 241 degrees? All right, last one. Give me a second. I know the bell's going to ring in a minute. Stay with me. Number 5. Sketch an angle of 7 pi over 6 in standard position. Do you have any idea what 7 pi over 6 looks like off the top of your head? But if it was in degrees, would it be easy? So move it to degrees. Let's take 7 pi over 6 times 180 over pi. Pi's are going to cancel. 6 goes into 18 30 times. So that looks like a 210. Is that a lot easier to sketch? Okay. You probably can't sketch radians yet. You will be able to next week. But yet you probably can't. So convert to degrees. It says sketch a 210. What quadrant does that fall in? Third. That's my 0. That's 180. 210 is here. Positive 210. So 210, give me 1 second, equals 7 pi over 6. The second part says find a coterminal. That's just when we add and subtract what number? 360. So I can take 210 and add 360, or I can take 210 and subtract 360. And those will get me those coterminal angles, the ones that keep bouncing back to the same one. Okay, homework's on the next page, 308. It covers exactly what we just did. Take your time there. Have a great day.